Hello, and welcome to Kryptonite Physics. Today we will discuss the physics of a mass on a rotation, how and why this physics is kryptonite. First you need to understand the basics of the physics involved, using simple maths anyone can do. We have a rotation, with a mass, marked in red. The red mass rotates at a constant tangential velocity, marked with the arrow. The arrow length is proportional to the velocity, in this case it's 7 centimeters long, representing a velocity of 7 miles per hour. What is happening to the mass? If we know the value of the mass, the radius, and the velocity of the rotation, we can work out that our mass has a centrifugal force acting on it, at a constant value, at all times. Most importantly, remember that the force value and direction is a constant for the red mass. Now we get to the most important part of rotation physics, our kryptonite physics. And why it is kryptonite. This is called wheel rolling without slipping. The physics name is rigid body rotation with translation physics. Search for rigid body rotation with translation, or wheel rolling without slipping. You will find tons of examples, some complicated, some simple. With this physics, you can work out what is happening to our red mass, when two movements are happening at the same time. That is, a rotation with the rotation center moving. This is the same wheel, same red mass, at the same tangential velocity. This time we are adding the forward motion of the wheel. The velocity of the wheel's center is 7 miles per hour, in a straight line. What do you think is happening to our red mass now? The same as before? I don't think so. Look at the center of the wheel, it's at a constant velocity of 7 miles per hour. Compare it to our red mass. The red mass is moving in front and behind the center, so something else is going on. It's going faster and slower than the center. It's the job of this physics to work out what is happening. How do we do that? We can use this site's vector addition tool. We can also do it by hand to get a better understanding of vector addition. Look for top to tail vector addition. All you need is a ruler, protractor and a sheet of paper. We place the two 7 centimeters arrows in the direction of travel, for each of the two velocities onto the red mass's position, representing the tangential and linear velocity. You add our two vector arrows together. By adding the two vectors together, the resultant vector arrow length and direction is our answer. If the arrow is 10 centimeters long, that is 10 miles per hour, in that direction. Adding the two vectors, we get the resultant velocity vector. This is the resultant velocity for each point on our mass. It changes in length and direction. That is, acceleration, at a changing rate, of our red mass. Comparing the rotation alone, to the rotation moving, we see a big difference for our mass. One is always at a constant, the other is not. Take some time to understand the basic physics, understand the difference for the mass. It's not intuitive, but it is a physics fact. This is important for the next step. Pause this video, have a break, go and look at the physics, check out top to tail vector addition. Links in the description. Relative motion. Inertial reference frames. What is an inertial reference frame? It is a frame of reference, moving at a constant velocity in a straight line, like this train carriage. Any movement or lack of movement within it is as if it is on the ground next to you, watching the carriage go past. The fish in the bowl moving in the carriage are the same as they would be on the ground next to you, watching the carriage go past. It is a fundamental part of physics and astrophysics. I can show 1,000 examples that this is true. I can show one where it is not. The mass has changed to a brass B. This could be you or me on any rotation that is moving. You now know the difference for the two rotations, one moving, one not. What happens to the mass when the wheel is placed in the carriage? Rotating at the same tangential velocity with the carriage's velocity at 7 miles per hour. What changes? Nothing changes for the mass. It only changes for the observer. The observer in the carriage can only see a static rotation. Observer's position cannot change the reality for the mass. It only changes what they can see to calculate from. We are tricked into thinking what you see is the reality for the mass. The math changes, not the reality. According to relative motion and inertial reference frames, this physics should not exist. The center of the rotation is moving at a constant velocity in a straight line. It is, by definition, an inertial reference frame. What have we learnt from this physics? That the fundamental physics, for the rotating globe, moving around the sun, then moving around the galaxy and universe, is flawed. They are all rotations that are moving. We have invalidated relative motion and inertial reference frames. Without relative motion and inertial reference frames, none of it works. Any force acting on a mass, or you, will not be at a constant, due to your ever-changing velocity. There is a reason, in astrophysics, why they do not use rotating reference frames that are moving. The reason is, it all falls apart if they do. Pause, take a screenshot of the next 2 pages, and print them off. Go and challenge anyone who knows physics, with the information and knowledge you now have.